In 1801, physicist Thomas Young wanted to settle a debate that had raged for centuries. Is light a wave or a particle? So he designed a simple but brilliant experiment. He shined a beam of light at a wall with two tiny slits in it. Behind the wall, he placed a screen to detect where the light landed. Now here's what he expected. If light is made out of particles, like tiny bullets, you'd see two bright spots behind the slits, one for each path. But if light is a wave, the waves would spread out, interfere, and create a pattern of bright and dark stripes, just like ripples in water. What Young found was the full interference pattern, which meant that light was acting like a wave. However, the story does not end there. About 100 years later, physicists repeated the experiment, but this time they used a very dim light, sending one photon at a time through the slits. Even when fired one by one, the photons still built up the same interference pattern over time, which means that each individual photon was somehow interfering with itself. It was somehow going through both slits at once and then combining to create the interference pattern. They placed a detector at the slits to watch which slit each photon went through, and suddenly the interference pattern disappeared. Just two spots appeared on the screen, like you'd expect from light being a particle. This meant that simply observing the photon collapsed its behavior. This meant that the act of measurement changed the outcome. So what is light really? A particle? A wave? Both? Neither? In the quantum world, reality doesn't really exist. It just waits for you to look at it.